Welcome to Sweet Life Beat Life. We hope this video helps.
You start by confirming prerequisites and getting straight to work. Install transformers, datasets, accelerate, and a compatible torch. Then pick a base model based on accuracy versus inference cost. Once chosen, prepare your dataset in JSON or CSV, split into train and validation, and define tokenization rules so examples match the model's context length. Make sure to set a repeatable seed and verify a small batch run to catch shape or tokenizer mismatches before moving on. Now you run the core fine-tuning loop. Create a trainer or use accelerate with data loaders, set per-device batch size and gradient accumulation to simulate larger batches, and enable FP16 for speed if your GPU supports it. Choose Atom W, a warm-up scheduler, and conservative initial learning rate, then kick off training while logging loss and validation metrics. If eval metrics plateau or diverge, reduce learning rate or increase regularization. Once stable, run a longer fine-tune with checkpointing to capture best weights. Finish by evaluating thoroughly on the held-out set and saving both model and tokenizer. Push to the hub or store locally with clear metadata. For deployment, apply quantization or pruning and measure latency to confirm real-world performance. If performance drops or training fails, check tokenization mismatches first, then learning rate and batch size, and look for signs of overfitting or data leakage. A single troubleshooting tip: reproduce the failure on a small subset with verbose logging to isolate the root cause quickly.
Thanks for watching. Consider subscribing if we helped you.